Hi, so this is the second video of week number 2 for SOEN6441. This is going to be describing what is called extreme programming, which is one of the early examples of agile software development methods. It is, you can't say really it's a software development process, because generally speaking, a software development process involves a notion of, actors and activities and artifacts. Extreme programming is much more of a prescriptive kind of model that advocates that you take care of certain precepts as you are developing software, for example. So let's go to the slides. So this extreme programming, go back. Extreme programming was designed at the end of the 1990s mainly by Kent Beck, who was a very experienced, who is still a very experienced software developer. He had been involved in teams, a lot of software development teams in the 1990s, and was faced with a high rate of failure of software development projects. And the way he analyzed it using his experiences, he figured out that at this point in time, there was more and more pressure for everybody to use these predictive methods, such as the rational unified process, that were getting more and more, in use in the software development industry, and that they felt that were not appropriate to be used for some kind of projects, that eventually led to failure of the projects. So they figured out that there needed to be much more agility involved in some projects, and that would benefit the whole software development industry. And that's how it created this method, you might say, which is called extreme programming. Now, what is extreme programming? It's basically a set of what is called key features, 12 key features, that are these precepts that Kent Beck had expressed that you have to take care of as you develop software in an agile manner. So some might think, well, he's basically saying we should get rid of the controlling mentality, as to say we have to develop software in an extremely well organized manner, creating some artifacts along the way and so on. So basically, he says we should get rid of that. So basically, that says we should do things free for all kind of style. No. Okay. So basically, he said, yes, there has to be some more freedom as to how to do things and to embrace change and things like this. But then he also said, well, be careful. There's also some very important aspects of software development that you must keep an eye on if you want to make sure that you will also reach for success. Okay. So these are the 12 key features that he identified that are very important aspects that you should have as part of your journey to software development if you want to reach for success, even though you're advocating for agility. Okay. So what are these? First of all, it's not necessarily in the order of the most important to the less, it's just not in any particular order. First of all, he said planning game. So the idea of the planning game is that you should always have a plan, even though this is seemingly you're giving a lot of freedom as to in what order the things should be done. Not so. There needs to be a plan. For example, there needs to be a build plan, as I explained in the first video. Okay, so as you go, you should always have a certain plan, and the plan the plan should be somehow very precise for the next 2 weeks. There should be a plan for the next month, but the more you're looking in the future, the less the plan is clear. And as you're advancing, then you're defining the plan for the next, for example, 2 weeks window. And as you go, you give more details to the window as you advance in the future. So you should have a plan when you start, a general plan overall, let's say the build plan. And as you are starting a new build, then you have a detailed plan for this build. And as you go, you define the plan. Then he said you should have what is called small releases. So the idea is that you want to deliver software incrementally, and you should plan for these deliveries to actually be in a short time frame. For example, 2 weeks. You should not plan your next build to be 6 months. Okay, it should be something that is reasonable to achieve within a few weeks, okay? So that you get very frequent feedback and you have reasonable amount of things to do, which make it somehow clear as to what exactly you need to do, and you can actually achieve it quickly. And they get some feedback and go to something else, okay? So small releases. Then there's a system metaphor. System metaphor is basically the precept is saying that you need to have an overall idea of what is this project all about. So yes, it is about adapting to changing realities in the project, but everybody should keep an eye on what is the global picture of this project. So even though you're changing, that you're not starting to diverge or think of something else that the project is not, as the project is morphing into something else as the changes are being applied. Okay, so there should be some kind of global understanding by everybody in the team, including the client and the development team, as to what is this project, what is the general goal of this project. So everybody keeps an eye on this general idea so as to not diverge from it. Then there is notion of simple design, which goes hand in hand with small releases. As we will see later in this lecture, there is relationship between these precepts. Okay, and that's very important to understand. You might think some of these precepts are not so important. Yes, there are some that are more important than others, undeniably, but there's also the fact that some precepts actually depend on other precepts. And if you remove those, if you have this precept here and then you remove this one, then this one does not have the necessary basis for it to be effectively working, okay, or possible to implement. So simple design basically means one of the goals when you do a small release is to do things quickly. And one of the ways to achieve things quickly is to do things simple. Okay. Essentially what it says, simple design says, if you have a certain problem to solve, there might be 10 different solutions to solve this problem. Essentially, you should choose the one that is the most simple, that actually is able to solve the problem, so that it's simple to understand and it's simple to implement. Okay. And it's able then to be implemented quickly. And it's not overly complex to understand so as to induce overhead in people trying to understand it. And another important one is testing. You might know that Kent Beck is one of the people that were advocating at some point for what is called test-driven development, which basically says that as you develop software, you should design the tests before you develop the software, and that tells you to develop the software in the right direction as to avoid the flaws that are tested not to be there by your unit tests. Okay, You might know also that Kent Beck was one of the designers of JUnit, which was one of the, or unit testing, which was one of the cornerstones actually of his methodology. Okay. Then there's the notion of the refactoring. I emphasized that in the previous lecture. Refactoring is one of the key aspects of extreme programming because it allows you to actually keep an eye on the good structure of your code. So between different iterations, you should or you must have some refactoring operations that will make sure that for the next operation, that the structure of the code that you have, your code baseline that you have before you start a new iteration, is of good structure. Okay, because if you don't keep an eye on the good structure of your code and you continue doing more iterations, it's going to become more and more and more messy, and it's going to become more and more costly to actually deal with it and add upon it. And that's the one of the main dangers that you run against when you are doing agile methods. Another one is pair programming. Pair programming is essentially saying that there's no such thing as you program as one person in front of one computer. There should always be two persons in front of one computer. Yes, there is one that has the keyboard in front of them. There's one that is typing, but there's also another person beside this person that is observing what they're doing, that is making some research about I don't know, the API of a certain class that they want to be using, or that is designing the test cases for the code that is being developed. So essentially, it's saying that two brains are better than one when programming is involved, and that's pretty much true. Even though there's a strong tendency for people that are to become programmers to be loners, this is a myth. This is not a good sustainable way of thinking. If you want to become a programmer, to think that you're going to be alone. There's no such thing as a programmer that works alone. You can be doing some of your work alone, but at some point you have to get in a team to do software development. Extreme programming advocates that yes, there's, let's say, a team of 10 people. They should always all work as pairs. Not always the same pair, but every time there's somebody programming, there should be somebody sitting beside them, helping and looking over what they're doing. Collective ownership. So that's basically saying that as there's, for example, 10 different people working on the code, there's no such thing as this is my code. And if you want to change this code, you have to ask me and I will change this code. There's no such thing. Simple reason is that if you have to wait for somebody to change the code, then this induces some overhead. Okay. So you want to work as fast as possible. There's no such thing as we're going to wait for somebody to apply a change. So the code belongs to everybody. So that involves that you trust everybody and that you are humble enough to totally share your code and accept that everybody can change your code. Okay. You see that it involves sometimes changing of mentalities when you introduce precepts like this. That's something I'm going to cover later on in this lecture. And there's the notion of continuous integration. So the idea here is that you are developing code and you're adding, when you're doing some incremental development, you have an existing code base and you want to add to the code base. So you take some requirements and you implement some code that is going to implement this, and you add this code for the new requirements upon the code base that you already have. So continuous integration says, as you're writing some code, you have to make sure that it integrates with the code that other people are also doing at the same time, because you might have, say, 5 or 10 people that are at the same time implementing new code to implement, let's say, the 10 requirements that we're working on right now. So basically, continuous integration says there's no such thing as people are working in isolation, and then at the end, basically, we integrate things together. No. Every day, several times a day, as people are working, they basically integrate the code several times a day. Okay. You don't wait until it's perfect to integrate. You continuously integrate the code. Another one is sustainable pace. So basically what this says is that people should not work more than 40 hours a week. Now that might be a total surprise for you because the tendency is notoriously for people, especially in software, to work many more hours than that. People with experience such as Ken Beck have seen firsthand that people that think they can work for a long time for 70 hours a week, these are the people that will fall sick and will go away. Okay, so that's what that makes absolute sense, especially myself. I know that myself. I used to be a person that would work like crazy. I realized at some point that no matter how I think this is how I work, or that I'm Superman or something, I'm not Superman. Okay, nobody is Superman or Wonder Woman. Okay, so you have to be careful as a manager of a company that if you push your people too hard, they will actually fall sick or go away because you push them too hard. Okay. And then once they go away, then the knowledge that they had about the projects that you have in place is going to go away. You're going to have to hire other people that don't know about your projects. It's going to slow you down. Okay. So you want to keep your people. One of the ways to avoid that they go away is not to force them to go into overwork. Okay. So sustainable pace. So you see that this has nothing to do with how to do the programming. It's just a precept that tells you be careful of overworking, of putting your people in overwork, because it will affect your productivity in the long run. In the short term, it might be good if you overwork people, but if you do it, for many weeks and months, they will go away, either because they fell sick or they will get sick of working for you. Before last one, on-site customer. So one of the things we said about in the first video, when I described agile software development, it says basically communication is very important. That everybody that is in the team, including some of the client part and all your team members, must be locally at the same place so as to have a more efficient communication. Okay. You don't want, for example, that as your team is trying to do the build in 2 weeks, that they have to call the client several times a day, and then they face their answering machine and then have to wait for 2 days for them to give an answer to their request. Okay, there should be immediate answer to every question. Best way to ensure that is that the person is there with you in actually the same room. Also coding standards. So very important that as you share code with other people, that the code is readable and that the code is in the style, because as a programmer, sometimes you read other people's code is in a different style as you are. They don't use the same naming for their variables or their classes. Their layout of the code is different. So if you want to be as productive as possible, everybody has to write code that is in the same style, using the same coding standards, okay? So as to reduce the amount of time that people spend adapting to different styles as they read other people's code. So you see that it's about productivity. So you see that these ideas are not revolutionary. This is just all common sense things, common sense precepts that you should know if you have experience developing software. Okay. So here I'm going to go in more details. Of course, I might go quickly over some that I have previously described in the preceding slides. So here I'm going over sequentially all of them, providing you some more details. So first of all, the planning game. So description is that you should have, first of all, a build plan. So when you start, if you are to have, let's say, 10 different consecutive builds, you should have a good idea of what each of the builds will do. And the more closer to you in time are the builds, the more you should have a precise idea of what they will actually do. The more you're looking in the future, the more it's acceptable that you don't know exactly what's going to happen in these faraway builds. Okay. And the more things are in the close to you in the future, the more you should have a detailed plan. So for the next build that's about to start for the next 2 weeks, you should have a very good idea of what you're going to do for these 2 weeks. Okay. And as you move forward, then you advance this window of definition of your plan. Here I'm identifying also some possible drawbacks of each of these key features. Of course, then what it says, planning game says, well, okay, you should have a very good idea of what you're going to do in the immediate future, but the more you go in the far future, the less you have an idea what's going to happen. Now, that does not sit well with a client. If you sit with a client and then you say, oh, it's going to take me, let's say, 1 year to develop this software, you're going to give me, let's say, $100,000. And then they ask you, okay, tell me what's your plan. And then you show the plan and it's very vague in the last 6 months. They're going to be like, oh, maybe you don't know what you're doing. Okay. So you have to be, that's why the planning game is not very, you have to explain to the client, why is that so? Okay. Yes, that's what you have to do, but the client is likely not to be too happy about it. So what, here, and why does it work in XP? I'm trying to make a link between the different key features, because most of the key features are depending on other key features. So the build plan is allows you to have a good vision of what you will achieve. Okay, and then small releases enables you to concentrate on the immediate future. So small releases, you will need to define what is exactly the set of requirements that you will implement in the next build, the next release. And every time you come to the next build, to a new build, then you have to redefine it to the planning game for this particular build. Here I'm describing in this fourth bullet here, how will we do that in the project? In this case, for the planning game, I have defined a build plan. So there's 3 different builds, and I have predefined what will be the features to be implemented in each of the 3 different builds. And I will give them to you sequentially. You will not know what are going to be the features to be implemented in the upcoming builds. I'm going to be giving you the requirements for the first build. You're not going to know what's going to be the requirements for the second and the third build. For the simple reason that I don't want you to work on the other requirements. You should not know what's going to be in the future, just like in real life when you use this model. So the build plan is something that I do. In real life, you would have to do it. In this case, it's going to be done for you. Of course, then you will receive this list of requirements. Then you will have to figure out a plan in your team as to who is going to do what to actually implement these features. Okay, that will be part of the things you have to do. And small releases. So what is small releases? A release is a working version. So that's why I'm calling a build, is a working version of the software. It's a piece of software that is usable to achieve some features to be implemented. And that piece of software is usable. That's the key word here. It's just not a piece of code that does something. It's something that can be used for a useful purpose from the perspective of the client, for example. Between the releases, well, when you release the software, it should be usable. Between the releases, then it may become in an inconsistent state that is not useful. But then when you release the next one, then it becomes useful again. Potential drawbacks. Small releases mean that the time spent on getting the releases to work, you need to spend time to actually release the software. You need to test the software, you need to prepare it for delivery and so on. So you need to invest time to actually make it deliverable software. Depending on what's the agreement you have with your client, if the software, this build, is actually going to be used in the workplace, of course, much more care has to be invested to properly test it and so on. If the client does not need to have this build to be used in the workplace, then maybe you would need to invest less time and make it operational. So that depends on the situation. Supporting features of small releases. So the planning, as I said before, when you do a small release, this is a build, so it's heavily related with the planning. As you go to the next build, you need to do the detailed planning for this build. So as you go, you define you redefine the planning, the build plan, and then for the next build, you define a detailed plan. Continuous integration is heavily related with small releases. So a small release might be every 2 weeks, you will deliver an operational version. But within these 2 weeks, every day, several times a day, you should do continuous integration. Okay. People often mix small release with continuous integration. Small release is, for example, every 2 weeks, whereas continuous integration is several times a day. Okay. If you don't do continuous integration, as we will see later, the danger is that your different developers will work in isolation. And then when you will integrate, the longer they spend in working in isolation, the more they're going in their own direction. And the more likely it is that when you merge after, there's going to be more merge conflicts. That's why you want it to be continuously integrated, so that people work a little bit, merge, work a little bit, merge, work a little bit, merge, instead of working and going far away, and when they merge, there's a lot of problems. Testing, of course, every small release, there should be testing that is done to test this build. Okay, so for every build, there should be new tests that you design. And then the simple design is, of course, as I explained before, heavily related with small releases. If you want small release to be deliverable in 2 weeks, you should not overly invest time in complicated solutions. In the project, every build is going to be predefined. Okay, so you're going to have 3 different builds. These are going to be 3 different small releases. System metaphor, well, I already explained that before. System metaphor is this, overall story or plan, or not plan, but overall description of what is the project, so that everybody keeps in mind, always keeps an eye of what is this global definition, so as to keep that in mind as we go, and that we continue in the same direction and we don't diverge from this initial description. Okay. So this entire idea of agility involves the notion that we deal with change. One of the things that we don't want to change is the overall definition of what this project is all about. So it's important to have this definition and keep an eye on it as you go. In our project, somehow the system metaphor is the initial project description. Okay. So, and we will have very frequent discussions during the live lectures about this, and then we'll keep an eye, we'll make sure that we always keep in the same direction. So simple design. So essentially the idea here is that when you have a certain problem to solve, a certain requirement to implement, if you have different solutions to this requirement, then you should choose the one that is most simple, that still meets the requirement. Okay. Yes, experience will also become a factor in choosing a solution that is also better suited for maybe future requirements that will come later, if that's there's critical decisions to be made according to this. But the general idea is that you don't want overly complicated solutions that delay you in their implementation. Of course, drawbacks is that sometimes a simple solution can prove to be simplistic, in the sense that it will become very quickly a hindrance rather than a real solution. Okay. So there's a balance to be had between a solution that is simple versus a solution that is simplistic and becomes a problem. Okay. That requires experience to determine what's the difference between the two. Related features, refactoring. So sometimes you may implement a simplistic solution and then realize between the two builds that it was too simple, and if you want to be able to implement the next set of features, you need to somehow change the structure so that it can actually enable the next features to be implemented. So refactoring can help you make your overly simple solution that was developed in the previous build to accommodate the future features to be implemented. Simple design is also related to pair programming. As you're doing design, sometimes you make mistakes as you're doing a design because there are certain aspects that you didn't think of. Having somebody sitting beside you and somehow analyze what you're doing and analyzing your decisions may help to actually avoid making some mistakes, design mistakes. Next key feature is testing. The testing is one of those very important features. Kent Beck, as I mentioned before, is one of the persons responsible for the notion, the development of a notion of unit testing frameworks such as JUnit. So he's very adamant about unit testing. He's also behind this notion of test-driven development, which advocates that you should design your own tests before you actually design the actual code that is being tested. You may want to do this, maybe you don't want, but it's basically is saying this key feature is saying you should have unit tests, as we will uncover also with when we talk about in more details about refactoring. We will see that refactoring actually necessitates that you have unit tests in place. Okay. So unit tests are basically there to test units of the code, a unit being a certain function or member function of a class. So you basically exercise the execution of a class using a certain number of parameters and certain context of execution of this function. So basically that you are making sure that the functions that you have implemented are behaving according to their specification or what they're supposed to be doing. So potential drawbacks of this is, of course, as you're designing your tests, this implies overhead. So the more tests you have, the more you spend time writing the tests and the less you actually spend time on writing the actual code. So then the question becomes, how much time do you spend implementing tests? What are the methods or units that are worth more time implementing tests for? That generally speaking, that requires experience to actually figure out the answer to these questions. So you don't want to spend time testing a function that is executed once in a very long while, but you want to spend time test functions that are executed very frequently for key aspects of the execution of the software. So yeah, testing is very important, but also requires judgment or experience to figure out where to actually invest time. Which units should be actually more important to be tested. So what are the supporting key features? Simple design. So if you have simple design, it is somehow by definition easier to test. Okay, the more your design is complex, the more it's likely that it is actually being harder to test. So if you're doing pair programming, also the one of the two persons in the pair can actually work on the tests while the other is working on the code. Also determining what is, because for each function you want to test, or for each unit, there should be a number of tests for every unit. So determining what is the test, what is the nature of each of the different tests actually requires some elaborated thinking about what this code is and how it should be tested. So it can be that the main programmer is writing the test while the other one is thinking about the other upcoming tests to be implemented, for example. Very important also, it's very good for your morale when you actually run the test. Let's say you apply a change to a certain unit and you apply the tests and then all the tests pass, then it gives you good confidence that what the change that you apply on this unit did not break this unit. Of course, it's not a steel-clad assurance, but at least gives you some confidence that the unit that you just changed you did not break it. Okay. Of course, one of the things is that you want to run the tests automatically. So you absolutely need to have a unit testing framework that is somehow integrated with the IDE that you are using. Ultimately, what you also want is as you commit the tests that you have a continuous improvement, you're using a continuous improvement framework that makes it so that is connected to your repository, that makes it so that when you commit code, it actually runs the tests in order to accept your commit. So it's better if your tools are integrated like this, so as to make a better use, make sure that all the precepts are properly used and backed up by real life use by the tools. Refactoring, another extremely important, as I said repeatedly now. So refactoring is very important to ensure important activity that you do in between your different builds to ensure to keep your the structure of your code in reasonable good structure, so as to avoid that the structure of your code would be degrading too much as you are applying more changes. Okay, so refactoring is an important aspect that you need to have in place in order to have sustainable development, to make sure that you will not go to a point where the code has become so messy that you actually cannot continue continue the development. Of course, if you are to do refactoring, you absolutely need to have code ownership, because the person that is refactoring a piece of code is not necessarily to be the person that actually did this code. So collective ownership, as soon as you're talking about continuous improvement, these things, you absolutely need to have collective ownership. Coding standards also, refactoring and coding standards are related because as you apply refactoring, you need to be able to understand very easily the code of other persons in order to locate refactoring targets in the code. Pair programming makes also refactoring less risky because there is risk involved in refactoring. Refactoring basically involves that you change the code. Anytime you change the code, you may actually break it. Another aspect of it is refactoring. You may have a lot of different refactoring targets. You may collectively think as a team that there's, for example, 20 different places where we may change the structure of the code. You need to come up with some kind of consensus as to which ones you will actually, in fact, apply. Okay, so that's why it's better to have different opinions as to which refactoring operations will be, in fact, applied. Which ones are more beneficial, for example, because you are going to spend time and it's risky to do refactoring, so might as well invest time and risk on things that are worth it. Refactoring actually absolutely requires unit testing. The idea, as we will see later, behind refactoring is that you select a certain unit to be refactored, you apply the tests on this unit, they should pass, then you change the structure of this unit, then you reapply the tests. And after the change, the tests should all pass again to make sure somehow that you did not break this unit by applying the change. Continuous integration will give you rapid feedback about the problems. So if sometimes when you commit some code, there are some red flags that will be uncovered as you're trying to commit. There might be areas of the code which are people realize that they are more problematic. So that might be a way that you actually can identify areas of the code that need to be changed or refactored. So we will do refactoring in the project in the sense that after every build, actually before every consecutive build and build number 2 and 3, I'm going to ask you to actually identify refactoring targets, and then to make a selection and then apply refactoring operations before you start the next build. Pair programming, so that's basically involving that as you are doing programming, that there's really 2 persons in front of the computer. One is typing, yes, but the other one is probably thinking about the design of what we're doing right now, or thinking about the testing that should be applied on what we're writing right now, is keeping an eye on what the person is coding. or is making some research as to, for example, the API of a certain class we want to use, so as to make the programmer itself more efficient in their coding. Potential drawbacks: pair programming may not be done efficiently. So you have to get used to it in order for people to actually work efficiently as a team. Okay. It requires practice to do it in an efficient manner. Supporting key features of pair programming, coding standards. So sometimes people might not have the same opinion as to what is the variable names you should use, what is the coding format that you should use. If there is coding standards, that will avoid these arguments as pair is actually doing the programming. Simple design, refactoring, and writing tests together may avoid that mistakes are being made. That's one of the goals of pair programming, that, you know, very often when you're doing programming, you make a silly mistake, which might take you a long time to actually figure out. If you have somebody else that is looking at the silly mistake that you're doing now, they may actually be able to see it like within 1 second and you fix the problem, rather than spending 20 minutes of very frustrating time to figure out an error that you've made that someone else might have located in 1 second. That's the nature very often of programming. Sometimes you make a mistake and you can't see it. So somebody else very often can see it very quickly. Okay, so how we will do this in the course. Essentially we will give responsibilities to people. Then maybe you can do some pairs with somebody with experience, paired with somebody with lesser experience, so that you can benefit, that person with lesser experience can benefit from the experience of the first one and then become a more productive member after having paired with this person. Okay. That's one way to, that's one of the goals also of pair programming, to benefit from each other's experience, right? Collective ownership. So it's basically meaning that anybody can change any part of the code. There's no such thing as this is my code or your code. All of the code belongs to everybody. Potential drawback, of course, if some people are not respectful of the other people's code, then they might make changes to other people's code which are wrong, because somehow they didn't understand the code correctly. They make a change, break the code. So you have to be very careful when you change any code, not only other people's code for that matter. And that can also be very frustrating if I wrote a piece of code and somebody else comes and then makes a change and breaks it. If that happens repeatedly, it can become very frustrating. But that's all part of what you need to change within you in order to be able to work with this kind of methodology. That's something we'll come back to later on. With continuous integration, you avoid to have breakdowns on a larger scale. So yes, the code belongs to everybody, but everybody is, bit by bit adding to the code, and everybody works with everybody else's code. So you're likely over time to actually have worked, as any individual is likely over time to have worked on almost all of the code. Okay, so that makes it easier in the long run. Also, collective ownership is connected with tests. Because as you have tests, then you're less likely to actually, well, maybe you will break down, you break some code, but when you run the test, then you'll be warned that you actually broke the code. That's about it for that. For collective ownership, of course, then what we're going to be using is a repository, like a GitHub repository or a Bitbucket repository. That's the main way that you're going to do a collective ownership on your project. The idea is I want people to commit code very frequently. Okay, so you should expect that I will expect that when there's a project demonstration, that we will observe the number of commits in your code. There should be dozens and dozens of commits. Okay, don't wait before you commit code. Sometimes people wait. That's contrary to how it should be done. Okay, when you do some coding, as soon as you have something that is significant, you should commit it. Okay. Of course, you should commit only things that work. Of course, here the next one is continuous integration. And this, of course, is heavily related with collective ownership. Okay. Continuous integration is about committing the code as frequently as possible. It's heavily related with simple design and small releases. Small releases is to develop builds every 2 weeks. Continuous integration is integrating the code several times a day. It's using, of course, a repository. So this is the one, everybody should know how to use a repository. If you don't, then please take the opportunity of having done this course to take this habit. If you don't have knowledge about using a repository, that's probably going to be the best thing that you will get from this course. Almost every company is nowadays using a repository. Sustainable pace, I already explained that one before. So it's about the fact that you should not overwork your people. The idea of Agile is that, one of the ideas of Agile is that you should not build so many artifacts which are containing a lot of information, which you might have to update if it needs to be changed. The drawback of this is that you don't have this information written down. Where is this information? If it's not on paper, it means it's in people's minds, in people's heads. And then if these people go away because they fall sick because of overwork, or if they go to another company because they don't want to work for you anymore because there's too much work, then their information that is in their brain is going away. Okay, so you don't want to accumulate information in documents. It's in people's minds. You want to retain your people. One way to retain them is to treat them well, which means not overwork them. That's one of the ways to treat them well. And one of the other final ones is the on-site customer. So that basically says there needs to be good communication, efficient communication between everybody in the team. That includes the people from the client side, because the client is the one who will answer your questions as to what the software should or should not do. If there's a communication breakdown somewhere sometime between developers and the client have to wait for the developers have to wait for the client to answer their questions, it introduces delays. So solution to this is to always have somebody with you at the development side to actually answer your questions. Of course, then if this person knows a lot of things, that means they're extremely valuable persons probably for the client. So then the client boss, the boss of the manager of this company might say, well, I'm not going to lend you this very important person for 6 months as this software is going to be developed. So this is kind of a difficult one here. Okay. All this means that there should be very fluid communication between the client that answers questions and the developers. Okay. Then coding standards. So there should be one way that all the team is actually coding. Like coding standards include the naming conventions that you use for your IDs, for your class name, for your variables, the layout of the code, the general way into which you are coding somehow, file names, all kinds of things that are conventions that you use as you're doing your coding. The team as a whole should adopt conventions that are adopted by the team, and everybody should abide with that. The reason being is that you want, as an individual, you want it so that when you read other people's code, that it's written in the same way as you actually write code. If there's different conventions used by different programmers, then you read other people's code, it's written differently, it might take you a lot of time to read it, to understand it, and so on. You want to reduce as much as possible the time it takes to understand other people's code. So it should be written in a similar fashion. So in the project, I will ask you that you write down on paper a very simple description of what is your coding conventions, and that we should see in your code that you're respecting your own coding conventions. We will also ask you to write a Java doc. So that's one way, if we ask people to write Java doc for all the classes, it's an incentive for them to actually follow good coding conventions. Taking the habit of writing Java doc also sometimes forces or gives good incentive for people to follow the team's conventions. So there's also some values that are attached to the following of extreme programming, as I have highlighted in some of the discussions I just gave. The first value is communication. So you want to make things happen as fast as possible. One of the hurdles in effectiveness is actually miscommunication. Either that you want to answer to a question, person is not there, or that a person gives you an answer, it's not clear. So you want to have a clear and frequent and non-interrupted communication that is available between all the persons involved. So basically, what you want to achieve is to have a frequent verbal communication. So you don't want we don't rely on documentation. So the information is not stored in documents. So that means that information is information that you get from people. So you need to be able to, if you don't have documents and the information is stored in people's minds, then you need to be able to have access to these people in order to communicate the information that they know. Okay. So that's another adverse effect of not having documents. If you don't have documents, it means the information is in people's mind. You need to be able to talk to them physically in order to extract information. Another value is simplicity. So if simple things are easier to implement, simple solutions are easier to implement. So anytime that you want to do something, if it's more simple, it's by definition more easy to implement. Very often you have some programmers, you encounter very good programmers who have a tendency to want to optimize everything. Speed of execution or developing an algorithm that takes as less memory as possible might be an interesting exercise, but it's not necessary. In many cases, it's not necessary. So if you spend more time implementing an optimal solution that you don't need, then you're expending time for nothing, expending time and resources for nothing. One of the concepts related to that is the GIAGNI concept, which says basically an acronym for you are not going to need it. Okay. So basically saying that when you're doing programming, if you're about to spend some time on making something more clear or more efficient and so on, or making it more flexible for something you think you may need in the future, then think twice, and maybe the answer is no, I should not be doing this. If it's going to be needed sometime in the future, let's invest this time for when it will really be needed. Okay. If it's not needed now, don't do it. That's basically what it says. Feedback. So there's essentially 3 different ways that the feedback can come to you. Either it can come from the system, meaning the main thing here is unit tests. As you run your tests, it's for a way for the system to itself to tell you whether it is running correctly or not. Okay. So, and that's the main reason why unit tests are important, so that you are aware, you become aware if there is a problem that is occurring. Okay, it's a way for you to get feedback from the system. You may also get feedback from the customer as you present a build to the client. Essentially, they will tell you whether or not it satisfies them. If it does not, then you get feedback, and then you can take action to make it actually work the way the user wants. So again, you're getting a piece of feedback, and you can take action to fix the problem. You may also get feedback from your team. So for example, I was saying earlier, as the different team members have to deal with different pieces of code, some teammates might tell you, well, this class here, it's a little bit messy, maybe we should change it. So there's, yes, your fellow programmers will also give you feedback as to what may need to be changed. It also requires courage. So for example, as I was telling you before, like for example, pair programming. A lot of people have this conviction that they are a good programmer when they are alone and nobody's looking at them. Maybe that's true, but that's not realistic. Okay, in real life, you have to work as a team. Somehow, if this is your habit, along the way, you will have to change this habit and make it so that you can actually work in the presence of other people. Very frequently, especially when you are to deliver the software, you have to work as a team at the same place and learn to work physically in the same place, in the presence of other people. So you have to change your habits. It takes courage to actually admit you might be a very good programmer, but if I'm putting you in a certain situation, then you may not feel so good about being placed in a situation that you don't like. Okay, so it takes courage to be able to change your habits and to be able to put yourself in situations that you don't like for the better of the team. Especially if you have some shortcomings and you know about them, and then if you have to work in front of people and then expose these shortcomings to other people, some people may feel, for example, shame of not knowing this and that, and they don't want for other people to know. So it takes courage to admit somehow to other people that there are things you don't know and that you're not good at. Okay. So it takes courage to face your own shortcomings in front of other people. Or if you make a mistake, let's say you somebody designs a piece of code, you make a change to this code, and then you break the code, then this person might come to you and say, oh, you broke the code. And you have to admit, yes, that you did it. And it might not be a good thing for your ego to actually admit that you made a mistake. So that's, you know, there's a lot of ego involved sometimes in the mindset of a programmer. You have to be able to, for the good of the team and productivity of the team, to be able to accept that your ego sometimes will be there's going to be problems with your ego as you're working. Okay, that's basically what I said here. On the other side, as it requires courage to be able to, for example, admit your shortcomings, on the other side, you need to respect people and act respectfully towards them, and for example, not make fun of them or chastise them because they have a certain shortcoming, and be constructive and then help them overcome these shortcomings. So you need to be respectful of other people. You need to be respectful of yourself too. Sometimes self-respect is as important as respecting others. For example, when you commit code, you should never commit code that will actually break the compilation. Okay. You should never commit code that you know there are mistakes in the code. There are ways that you can actually use continuous integration tools that will make it so that it's not possible to submit code that does not compile, or that for which the tests will fail. If it's not the case, and you should really take a habit of never committing code that is wrong. So that's respect for yourself, and also respect for the team. Okay. You should always strive for high quality of everything that you're doing. So, because if you commit something which is of lower quality, then inevitably down the line, what it does is that it slows down other people or even yourself. Okay. We all know what happens. Sometimes you design sloppy code. When you come back a week later on your sloppy code, sometimes you have to spend a lot more time just dealing with the sloppiness of your code. That's not good respect towards yourself in the future. And as you are respectful to other people, then they will tend to actually also be respectful to you. So it's a two-way relationship, even with yourself. It will also motivate or avoid demotivation, which is a very important aspect of any company. You want to have motivated people. If people feel disrespected, they are much more likely to go away. And as I said before, people going away in an agile project management style is the worst thing that can happen, because the people have knowledge. If they go away, the knowledge goes away, and then you're in trouble. One of the last things, and most important, is embracing change. Sometimes people are not too hot about change. Let's say somebody wrote a piece of code, they're very proud about it, and they think it's flawless. Then if you tell them, well, we need to change it, then they might be refractory to actually change their own code. Or if the client tells your team, here's my list of requirements in the beginning of the project, the client tells you this is not going to change, and then later on the client comes up and says, oh, you know what, I changed my mind, I had a new business opportunity, I want to add this, and that. What if you're really doing agile methodology, you should welcome the change and tell the client, yes, we will do that for you. Maybe you're going to say also it's going to cost you more, but you should, accept that you should be telling the person, yes, we will make that for you. If basically you should see that as a way that you can improve what you are developing and not as a hindrance to your productivity. So that's it for that. So I hope this was clear. We will discuss that in the lectures, the live lectures, as to how we will actually do that in the project. So in each of the 12 key features, I tried to be clear at the bottom, describing how we will do that in the project. We will discuss that in the live lectures as we go. Thank you.